Hi folks, we're going to take a look at number 6C from part A of the Unit 3 assignment. So here they give us this function and they want us to determine any discontinuities and if there's any vertical asymptotes, the behavior on either side of the asymptote. All right, so here I see the numerator is just always equal to 5. So the only place where I'd have a discontinuity is if the denominator is ever equal to 0. So let's try solving that, see if that happens. So here if I set 2e to the x minus 8 equals 0, I'll start by solving for e to the x. So bring the 8 to the other side, divide by 2. I get e to the x equals 4. And I can solve this by taking the natural log of both sides. So ln of e to the x just gives me x, since of course natural logarithm and e to the x are inverses of each other. And so here I just have ln of 4. All right. So this is going to be a discontinuity because the denominator is equal to 0. And I know it's going to be a vertical asymptote because as I approach this number, the denominator is approaching 0, but the numerator is approaching something other than 0. So if they were both approaching 0, there was a possibility that there might be a hole. But that's not the case here. So here we have a vertical asymptote at x equals ln of 4, and that's the only discontinuity that we have. All right, but they want us to go a little further. They want us to determine the behavior to either side of this asymptote. Okay, so what I'm going to use a number line to see what the sign of the function is on either side, because that'll tell me whether it's going to positive or negative infinity. So if I set my number line and I see that the only place that this function can change sign, in fact, is at ln of 4. All right, so I just have to determine the sign of this function on either side. Now, I'm, could use a calculator here, but I'm going to see if I can get away with not using a calculator to do this. All right, so I know that ln e is equal to 1, and 4 is bigger than e, because e is about 2.72. So I know that this number is going to be greater than 1. So I'll just pick 1 as my value to the left. All right, so if I stick this into my function, well, the numerator is always positive, so I only have to look at the denominator. Well, here, e to the 1 is about 2.8 times 2 is definitely less than 8, which I'm subtracting, so I know this has to be negative on the left-hand side. Okay, and again, if you prefer not to do this analysis, you can just figure out what ln 4 is approximately, and then pick numbers and stick them into the equation. All right, so let's try to pick something that's bigger than ln 4. Well, one thing I know is that, if I take this function here, I know that it's going to be smaller than y equals x. So whatever, ln of 4 is, I know it's going to have to be smaller than whatever the value of y equals x is at 4, which of course is just 4. So I know 4 is going to be something larger than ln 4. All right, you can check that on your calculator if you like. So again, I just have to look at the denominator. So here, if I take e to the 4, well, that's about 2.8 to the 4. Let me pick even a smaller number, 2 to the 4. Okay, 16 times 2 is 32. So that's already much, much larger than 8. So that means even with e, it would be larger than 8. So I know that on the other side, it's positive. All right, so that tells me that to the left of ln 4, the function is going to be approaching negative infinity, since the function is always negative to the left of that. And here it's going to have to approach positive infinity because all the y values have to be positive to the right of that number. Okay, but I'm going to write it using limit notation. So we have that the limit as x approaches ln 4 from the left of my function s is just going to be equal to negative infinity. Okay, and my limit as x approaches ln 4 from the right of my function s is going to be approaching positive infinity. All right, so just a quick recap. The main way we find discontinuities are when the denominator is approaching 0, which was the case here. So we solve that, and then from there we use the sign of the function to determine whether it was approaching positive or negative infinity as we approach from the left and from the right. All right, that's it for this one.